Hello guys, welcome to JEEmathstudy.com where you can learn how to solve JEE mathematics problems. This is a complex numbers problem which was asked in AIEEE 2002. It states, if modulus of z minus 4 is less than modulus of z minus 2, its solution is given by A. Real part of z greater than 0, B. Real part of z less than 0, or C. Real part of z greater than 3, or D. Real part of z less than 2. Problem statement tells us that there is a complex number z. From z, two more complex numbers are derived, that is z minus 4 and z minus 2. They have taken the modulus of each of them, that is modulus of z minus 4 and z minus 2, and they are saying that modulus of z minus 4 is less than modulus of z minus 2. From this inequality, we need to find the range of real part of z. As you can see, there nothing is given apart from this inequality, hence we will start with it. That is, mod of z minus 4 is less than modulus of z minus 2. Now we will square it. You may ask why we are squaring it. I will tell you that later. Before, I want to explain one important concept of inequality. See, if we had equality sign in between LHS and RHS, then there would have been no problem while squaring both sides. But instead, we have inequality, in this case less than sign, then squaring both the sides may or may not change this inequality. Now, to find out whether this sign will change or not, we will use following concept. According to this concept, if there are two positive real numbers m and n, and another real number p which is also positive, then after raising m and n to the power p will not change its inequality. We will check these conditions with our inequality. We have moduli on both the sides, LHS and RHS. Hence, they can be only 0 or positive. As there is inequality in sign in between, they cannot be 0, they can only be positive. Hence, first condition is satisfied. Then they are raised to the power 2. Hence, the second condition is satisfied. As these two conditions are satisfied, this must be true. That means the inequality will not change after squaring. The reason why we are squaring LHS and RHS is because I want to use the following property, that is, product of z into z bar is equal to square of modulus of z. Using this property, on the LHS and as well as on the RHS of our inequality, we will get this, that is product of the complex number and its conjugate. Now we will use another property of conjugate of complex number, that is conjugate of z1 plus z2 is given by the conjugate of z1 plus conjugate of z2. That is basically separating this out. We can use this property on both the sides. By using that, we will get this. This is a conjugate of 4, but as 4 is a real number, its imaginary part is 0. Hence, the conjugate of minus 4 will be minus 4 only, and similarly, conjugate of minus 2 will be minus 2 only. Now, simply multiplying both these brackets, we will get this, cancel z bar from both the side, and taking z and z bar terms on one side and constant terms on the other side, we will get this z plus z bar is greater than 6. As we have got some information on the sum of complex number and its conjugate, we will use this property, that is real part of z equal to the real part of conjugate of z equal to the sum of complex number and its conjugate upon 2. You can see z plus z bar is already here. Taking 2 on the other side, we will simply get 2 into real part of z. Substituting that, we will get 6 less than 2 into real part of z. Taking 2 on the other side, we will get real part of z being greater than 3, which is same as C. Hence, C is the correct answer. If you like this video and find it useful, please share and subscribe. Thank you.